Hi everyone, our lesson is 5.3, so I will start now. So hopefully you got read or you got take out the notes. Okay, let me see the 5.3. I told you already, the 5.3 we don't have any calculation. We just got some of the common knowledge lah. I think you also know about the knowledge. Okay, let me see the 5.3. Okay, let's see the 5.3. There's a uses of the radioisotope. Okay, radioisotope, before that I told you they got alpha, beta and gamma, is it? Okay, that one is unstable isotope, okay, which decay and give out the radio emission. So now we need to know its uses. Okay, we separate by 4 parts. Okay, let's see the first one. There's in medic. Okay, in medicine, okay, there's the first part. We see which one radioisotope they got useful in the medic. Okay, let's see the first one. They're using the diagnosis for the certain diseases. Okay, provided the information. Let's see the first one is sodium 24. Okay, for this one topic, what you need to know is you need to memorize the name. The name of the isotope, there's a sodium 24. Then you need to know the half-life. Suppose we no need to memorize. We just want short half-life, or you say long half-life. Okay, one more tips to tell you for the medic. Okay, and under the medicine one, all the radioisotope must be short half-life. The reason is do not stay longer in our body. They will harmful. So this one is the reason. Okay, so from here you need to memorize the sodium. Okay, number 2, you need to know the function. Okay, the function is they want to detect the position of the blood clot in the veins. So this one is a function. So when a question just asked about sodium in the medic, what's the function, then you know. Okay, they want to detect the blood clot in the veins. Okay, now we're going to see the next one. Okay, they produce is a gamma ray and also the beta emitting the detect by the ray camera outside the body. How they function, we don't need to know. We just want to know the name. After that, the half-life is a short or long. Then you need to tell about the function. Okay, then next we go to the technetium-99. Okay, technetium-99, the half-life you see, 6 days. So normally the half-life is hours and also the day. They cannot go to be year or week. Okay, they used to detect the blood in heart. Blood in heart lah. So from here, they want to detect the blood, the blood inside the heart can be flow or cannot flow. So from here they're using the gamma emitter. After that produce a harmful alpha and also the beta inside the body. Normally we never using the alpha and beta lah. Why? Because alpha we know already. Alpha, the ionization is too high. Okay, if put inside the body, that means first one, they will stay longer. Because you stay longer, never mind, they will ionize all the thing, the cell inside the body. So we're using the gamma. Gamma, although they stay longer, but maybe the ionization is less. So they will reduce the harmful. Okay, you see, everyone normally they're using the gamma lah, because they want to put inside the body. Another one is alpha penetrating is low. Okay, they cannot penetrate in the body. So we're using the gamma. Okay, third one is the xenon 133. Okay, the xenon 133, the half-life you see also in days. Okay, gamma also. Okay, function, lung function. They want to check about the lungs. Okay, iodine 131. Okay, also in days, also gamma. Okay, function, they want to detect the thyroid gland. Okay, the thyroid gland. Okay, the next one is a 123. Okay, this one in hours, shorter a little bit. They want to detect the blockage in the kidney of the patient. They want to check is it inside or blocking or not. Okay, the last one is a cobalt 60. We got so many lah, but this until F1 is a normally they will ask one, the common one. Okay, just got one special. There's a cobalt 60. Half-life is a 5 years. 5 years means now your problem must be more serious lah. Let's see what is more serious. There's an internal cancer treatment. So that's why they must stay longer in your body for the gamma radiation. So cobalt 60 also used for the sterilize the medical equipment. So the equipment for the operation, they're using the cobalt 60 to scan it. Okay, so this one is what you need to memorize. Name, half-life is a short for the medic, just cobalt is the longest only. Then you need to know the function. Okay, let me see some diagram. We can see what is that. Okay, let's see the first one. This one is they show about the iodine for the thyroid gland. They want to checking. Okay, the next one also iodine. Oh, I think this one miss, is it? This one is a 1, 2, 3. Okay, how many to change? This one is a 1, 2, 3. You want to detect the blockage in the kidney. 131 is a thyroid gland. Okay, sodium 24. Detect the position of the blocking in the veins. Okay, blood blocking in the veins. You want to detect where's thrombosis. Okay, so this one is example. Okay, another example here for the medic sterilization. I told you cobalt 60. They want to scan about the equipment. Okay, after that, they say in the medic treatment, radioactive, the substance dangerous. So that's caused about the cancer if the body for the too long. So that means they cannot take longer time in the body. They must short. So that's why the short half-life it be used for the medic purpose. Okay, so this one is an example for radiotherapy. Okay, this one is some of the radioisotope we're using for the medic. Okay, then we continue for the second one. Okay, let's see the second one is industry. Okay, after medic, now we're going to see the industry. For the industry, the half-life, okay, the half-life is longer lah, never mind lah, because this machine only, is it? So they see the first one, strontium 90. The half-life is 28 years. So if the half-life longer, how we go to explain? So you just say last longer lah. Okay, last longer means we no need every time go to change to renew. So this one is why we're using the long half-life. They also use to measure the thickness of the paper. Industry emit the beta radiation. So from here the strontium 90, first one they want to measure the thickness of the paper. Okay, thickness of the paper. So let's see the example here. Okay, this one is an example. They want to detect the thickness of the paper. So you buy the A4 paper, everyone the thickness should be the equal one, because they already detect. Then they're using the beta, cannot using alpha, because alpha already blocked by A4 paper. So they're using the beta to detect. So that means when suddenly one part here is thicker already. So what happened? The reading become less. Why the reading become less? Because you thicker. The beta, some beta cannot pass through. So cannot pass through means the reading become drop. So the reading suddenly drop, then you understood lah. This one is thicker already. Okay, suddenly your reading is high. Means what? Means thinner. Your paper is thinner. So you need to adjust. Okay, how to adjust? Make the roller more closer. So make it become thin. Okay, so this one is strontium. Detect the thickness of the paper in the industry. Half-life is longer. Okay, the next one, let's see the diagram for the detect the thickness of paper. Okay, so this one is an example. They said they put the radioactive source opposite the detector. Now the detector is connected to the thickness of the indicator. Now the detector also detect the reading of the changes in the count. Thickness is measured with the thickness indicator. If the reading of the detector is less than the specific value, the thickness of the paper too thick, vice versa. So this one means they detect the reading. Suddenly the reading is changes, so they need to do the adjustment for the loader. Okay, so this one is a thickness control. So we continue with the another uses. Okay, another uses is sodium 24. Can you see the sodium 24 already repeat? Just now medic or sodium 24, now it's an industry. So when you want to mention or you want to answer the question, you must see, be careful. Is it industry or is it there's a medic? Okay, so this one you see here, the half-life just 15 hours. So just now I told you industry must be longer, is it? Why this one suddenly become 15 hours only? Okay, this one was testing leakage underground pipe. So that means they want to detect the water. So water you want to drink, is it? So cannot stay longer for your body. They also cannot under the ground. So under the ground means here got so many plant, is it? Then also got soil. So from here, they must using short half-life, faster to be disappear. Okay, so another sodium, detect the leakage underground pipe. Okay, under the ground, the pipe. Okay, how they go to detect? Okay, let's see the diagram. Okay, this one is an example. So here, the pipe is underground, is it? Okay, suddenly got one part that come out of water, but we don't know which part. So you need to trace. Okay, we're using the GM tube. Remember GM tube, alpha, beta, gamma also can use. Okay, so from here they say they emit the beta. Why we emit the beta? First one, cannot alpha because soil, thicker, is it? They cannot go through. So we're using the beta. You also cannot using the lead. Lead is too stronger already. Maybe go in the pipe. So now I don't want to go in the pipe. I just want to know where's the location of the water. So they say they're using the beta particle, add into the fluid. Okay, now they add into the fluid. So that means we never using the particle beta. Normally we using as a liquid form. We never using solid. Okay, liquid, why? They're easy to be mixed together with the water. Okay, so mixed with the water, that may be easy to detect. If they're using the solid, you still need to take some time, okay, to let it to be dissolved together with the water. So from here they add together to the fluid in a pipeline. After that, to measure the flow rate in the pipeline and also find the leak. So the radiation produced by the radioactive substance can be detected with a GM tube count placed above the ground. So you need to place above the ground, then you move. So a large increasing for the count rate. Suddenly one part, the red meter show bigger readings. Means what? That part means so many radioactive to come out. So when the radioactive to come out means here they got leakage. So that's why the water, they will come out. Okay, so this one is how they go to trace. Okay, along the part is okay, you find the reading almost a constant. Suddenly the part, the reading become high, means that part all the beta come out together with the water. So that's why they can trace the beta highest reading, means that part got leakage. Okay, so this one is the sodium 24, detect the underground pipe leakage. Okay, then we go back to the next one. Okay, the next one for industry, there's a americium 241. Okay, americium 241, you see what's the function. Okay, first one, you see the half-life is too long. Too long means last longer lah, they don't need to change oftenly. Okay, now we're using as a smoke alarm. Okay, how they function as a smoke alarm. So first one, alpha particle. Okay, they're using the alpha particle, emit from the source and ionize air molecule. So when the alpha particle go in, okay, then you find it, they're easy to ionize with the air molecule. Okay, when they ionize with the air molecule, they sure got negative ion and positive ions. So that means this one ionize with the air molecule, they will conduct electricity because you got two type of the ions already. And a small current will flow. Okay, so then you got ions, now the current start to flow through the smoke detector. Okay, when the current flow is okay, there's nothing happen. We don't have any silence, you cannot listen the sound. When the smoke enter the detector, okay, suddenly when the smoke to come out, okay, you find it, a shoot of the particle in the smoke that will absorb alpha. So that means when they just absorb the alpha, what happened for the alpha? Now the alpha is not enough. Okay, not enough to ionize for positive and negative ions. Means your current become less, is it? So when the current become less, okay, this decrease the current flow in the smoke detector, so they will trigger alarm. So from here, not because of current more, then they trigger alarm. Okay, because of the current not enough, because absorbed by the soot particle in the smoke. So that's why now current not enough, then trigger the alarm. So smoke detector now will function. Okay, so this one is what means of the smoke detector. They're using the alpha. Why? Because alpha is a good in ionization. Okay, let's see the diagram for the smoke detector. Okay, let's see this part. Okay, this one is an explanation. Alpha particle emit from the source an ionized A molecule. Then the ionized molecule conduct electricity, small current flow through. When the smoke just come out, okay, a soot of the particle, they will absorb the alpha. Now, decrease the current. Then after that, detector will trigger alarm. So this one is an example for the ions, positive ion and negative ions. Okay, then we continue to see this part. This one is more detailed. They show you this part is a no smoke. No smoke means your ion is enough, the current can go through, nothing happen. Okay, this part is when the smoke just come out. Okay, smoke uncharged the particles, circuit is broken, then alarm is triggered. So this one is a white color one, is a smoke. They got soot particle to absorb the alpha. So finally, they will trigger the alarm. So this one is an inside. Okay, when you just open the smoke detector, then you can see inside is what. Okay, this one is ionization, the chamber. Then this one is the alarm. Okay, one more. Okay, what you can see is, suppose the smoke detector, the shape. Okay, the shape become like this. Normally you go to the hotel or anywhere, you can see about this one. Okay, they just at the top, just on the ceiling there. Then the one is a smoke detector. Okay, not CCTV. This one is a smoke detector. Okay, then we go through the next one. Okay, the next one should be the agriculture. So before that, we learn medic. Medic, remember, because sodium 24, technetium 99. Okay, after that we got xenon 133, iodine 131, iodine 123, and cobalt 60. After that is the industry. Industry, we got strontium 90, thickness of the paper. Then after that we got sodium 24 again. There's a leakage underground pipe. Then we got americium 241. Okay, smoke detector. Okay, now we go to the agriculture, the third part. Okay, agriculture, first one we got phosphorus. Phosphorus, there's a half-life 15 days. This one is for the fertilizer. Okay, fertilizer means the thing plantation. Okay, plantation normally also for the short half-life, because they want the plant you want to eat, is it? The veggie lah, the fruit lah. So this one must be short half-life. Do not stay longer for your body also. Okay. Then the agriculture also including cobalt 60. Can you see got cobalt 60, got 2 already. This one is under agriculture. So this one half-life is 5 years, longest. Okay, where we using? They're using gamma radiation. Cobalt 60 using for food preservation. So you buy the apple, you see the apple, wow, so beautiful. Can be stay for 2 months also, never mind. Still okay, still can eat because of food preservation at the surface. Okay, then you buy the thin one, the canned food, the Maggi mee, that one also got food. They got expired date, is it? That one is a food preservation. That's why they got gamma ray inside. Then can stay for 5 years. So this one is what dangerous for the food preservation. Okay, see example for under agriculture, the uses for radioisotope. Okay, this one. Okay, phosphorus, there's a half-life 15 days. Okay, this one for plantation. Okay, for effectiveness fertilizer. Okay, cobalt 65 years. This one is a gamma ray. Okay, after that for using for food preservation. So you see the strawberry, wow, can be stay for longer time. Also can be eat. So that's why you buy, they call it to wash so many times before you want to eat. And some more, this one is a canned food lah. All got expired date, stay for longer. When you buy, they got stay for 5 years. That means inside got many for gamma radiation. That's why can be stay for longer. Okay, So we continue with the last part. Okay, the last part should be the agriculture. Okay, agriculture no finish. Archaeology. Okay, last part is the archaeology. Archaeology, we just got one. There's a carbon-14. Okay, the common one, carbon-14. What's the function? They want to use to detect the age of fossil. Okay, the age of the fossil. Okay, let's see example how to detect the age of the fossil. Okay, this one. They're using the carbon-14 with the half-life. You see the half-life so long. So that means they will be stable longer until 5,000 years. And also emitting the beta particle. Okay, living animal, example, and also plant have the no at the proportion of the carbon-14. That means in our body, we will automatic to produce a carbon-14 in our tissue. Okay, they remain constant. When living thing just die already, amount carbon in our body, they will almost slowly decreases because you cannot create already. So that means archaeology means they want to detect. Okay, they're using the trace, using the carbon-14 to trace the body. Okay, inside you still got left how many carbon. Okay, they're going to check. Is it your body got left how many carbon? Using the beta particle, is it? Okay, trace your body still left how many carbon. Okay, so that means if you die, how many years? That means they can count. Okay, if you die more than 100 years, more than 10 years, they also will know because the carbon in the particle, they will less. Don't care about the animal or plant or human. Okay, the carbon in the body, they will almost less year by year. Finally, they're using the beta particle to trace for this living for the die animal and also plants. Okay, this one is archaeology. So we finish about the chapter 3. Short, is it? So from here, what you need to know, memorize. Okay, medic. Then after that is industry. After that we got agriculture, and the last one is archaeology. Okay, so this one is what I want to show. Okay, so we finish about the 5.3. Now let's see some example question. Okay, this one is a one example question. Why is an isotope that admits the alpha particle not suitable for use as a tracer in a medicine? Can you see just now all the tracer in the medicine we're using gamma? We're never using the alpha. Okay, what's the reason? First one, you can say, oh, maybe the alpha penetrating too low. Yeah, I agree. Because you go in the body, is it? Maybe and on the surface, alpha cannot go in already. So the second one is alpha ionization is too high. It's too high, that means if they go in your body, they will stay there, they ionize all the cell in your body. That one is dangerous. So we're never using the alpha. Okay, so this one is an example why we never choose the alpha. We choose about the gamma. Okay, now I show you the answer. You can refer here. This one may be some of the question they will ask in the 4 marks question. Okay, if 4 marks, that means you need to give the 4 points. Okay, alpha particle have weakest penetration power. So has a range of few cm, remember? So for the beta, they still got meter, but for the alpha, just range a few cm, then finish already. Okay, the next one, cannot pass through the body tissue of the patient. Okay, number 3, cannot detect outside the body. Okay, cannot be detected outside the body. Okay, now the power ionization for the alpha is very, very high, and also will destroy the human cell. So this one is a 4 marks. Why we never choose the alpha as tracer in the medicine. Okay, then we go to the second example question. Okay, this one, diagram 1, they show the water detection system. Okay, to design by the student to detect the level water in a storage tank so that an outlet of the valve can be opened automatically when the water level is too high. Okay, water level is too high, then automatically the valve will open. So now they say the radioactive source and also detector are used to detect the level of the water in the tank. So that means the level too high, automatically will open. So you must something to detect the level of the water lah. So now the radioactive source contain the radioisotope. So explain how the outlet valve open when the water level is too high. So the first one you must say you're using what particle. So from here normally we using is a what particle we using the beta, is it? Okay, normally we seldom using the alpha because the penetrating too low already. Okay, if you're using the beta, so that means if the level too high, what happen? If the level is too high, means the beta, some beta cannot go through. Agree? Because blocked by the water. Okay, if some of the beta cannot go through, means the detector will show the reading decreases. Okay, suddenly you find the detector. When starting, okay, the reading is okay, constant. Then suddenly too less already, drop so much. So means the beta cannot go through the water. Now the water is over the level. Okay, when it's just over the level, so that means your valve, outlet valve controller, they will automatic detect, then they will open the valve, then let the water flow out. Okay, this one is an explanation. Okay, we also can see about actual answer. Just now is what we discussed lah. Now we see the actual answer. Okay, they say when the water level is too high, radioactive ray pass through the water. They can pass through the water, but the water, some they will absorb part of the radiation, absorb some of the part. So detector show the reading decreases. Detector activate. Okay, now they find the reading become less, now they activate. So the outlet valve controller open for the outlet valve, then the water flow out. Okay, you need to explain when starting, what happened, then absorb the part of the radiation, then last one is what happened. So this one is a 4 mark for the process question. Okay, then we continue with the question 3. Okay, this one is a technician. They want to detect the leakage of the water underground pipe. Okay, using the radioisotope and detector. Now you need to suggest what type of the radioisotope. So I told you just now we're using beta, is it? Okay, precaution, safety precaution. So now with this one is a 1 essay question, 10 marks. So you need to talking about the radioisotope. Okay, type. First one you can say beta, then you give the reason. Number 2 you can say about the form, solid or liquid. Okay, then one more is the safety. You can say about safety, what you're using. Safety, the shirt, what you wear. Okay, the shoe, what you wear. Then this one is detector. What detector you will use. Okay, the detector normally we're using this GM tube lah. Okay, then now we're going to see the actual answer. Okay, first one. Okay, one more, miss already, half-life. I'm talking about the half-life also. Okay, shorter half-life. Allow the time of the radioisotope to reach to the leakage site. Okay, another one is minimize. Okay, minimize for contamination of the environment. That means they do not stay longer at the soil. That will destroy the environment. Next one, emit is a beta radiation. Okay, because they can penetrate through the soil and not the pipe. Okay, easy soluble in the water. So we're using the liquid lah. So by using the form must be liquid, easy soluble in the water. So easy to dissolve the radioisotope in the water. Okay, now this one is a safety. Weigh the radiation batch. Remember the photographic batch. The first one. Okay, they also can say about the film batch. Okay, so the function is to monitor the exposure to radiation. Okay, you can find it what to monitor your exposure for the radiation. Do not let the radiation to come out. Okay, last one is wear the protective clothing shoe. So this one you also can say about your safety lah, because you wear already, so that means the radiation do not go through. Then this one is protective the shoe to minimize the technician from the exposure to the radiation. Because both can give the same reason, but we normally cannot write the same explanation. So this one you create another one. So from here they say to monitor the exposure to radiation. Okay, so from here there's a 10 marks answer for the essay question. Okay, this one is under radioactive. Okay, so from here we finish the lesson. So need to go is the tutorial now. Now you can turn to your tutorial page. Be straightforward to discuss the objective question. Okay, now we're going to see the objective question. Okay, objective just last question only. So you can try about that. Then I will show you the answer. Okay, let's see the objective. Okay, first one, they say which one is a true about the radioactive substance. So from here, you find it, the radioactive substance which one true. First one, sex of the fetus, no lah. Okay, identify the counterfeit. Note that one is UV light, is it? To detect the leakage in underground pipe. Yes, the answer is the C. Okay, want to detect the underground pipe. So answer is a C. Okay, answer is a C. Then we go to the number 2. They got JKLM. Which of the radioisotope is the most suitable as a tracer in the human body? Remember the human body half-life must be short, but don't be too short lah. How many minutes cannot detect one? So we take the shortest one here is a M, is it? There's a in hours. So we take this one is M. Cobalt 60 destroy the cancer cell because why we using cobalt 60? Can be destroy the cancer cell. Okay, so from here no effect, sure cannot lah, sure got effect. Okay, radiation for gamma ray, many also gamma ray, not just for cobalt. So this one not the best answer. Decay the spontaneous, everyone also spontaneous. So from here should be long half-life. Because cancer treatment is a long term of the diseases, so you need to take long time to be controlled it. Okay, now we go to number 4. Okay, number 4, the apparatus they use for in the factory, they want to detect the thickness of the plastic. Okay, plastic. Okay, so from here, which one radioactive would be the best? Okay, first one, detect the thickness, so the half-life must be longer. Agree? So day out. Okay, now sure alpha cannot use because there's a plastic, is it? So we just got beta. So from here your answer should be 100. Yes. Okay, now we go number 5. Number 5 is detect the leakage underground pipe. So from here they say radiative, which one we using detect? So that's why I call it to memorize. The answer is sodium. Okay, number 6 is volume of the paint. Okay, volume of the paint in the container. You want to detect. Okay, which of the ray is emitted from the radiation? So we're using which one? Okay, paint. Paint normally is what? Okay, using the paint, cannot using alpha lah, because alpha cannot pass through. Okay, gamma is too strong already over, so we cannot check. So we're just using the beta particles. Okay, now we go to 7. 7, they ask which one should be true. This one is what? Smoke alarm. So we're going to check. Cobalt 60 is used. We never using cobalt 60. We're using americium. The device work based on the penetrating power. No, we're using ionization. C. When the fire breaks, the particle smoke will absorb the alpha particle. Yes or no? Yes, because of the soot to come out. Let's see the donkey. Okay, the particle of the smoke increase the ionization of the air. Cannot increase, there's a decreases. So the C should be true. Okay, number 8. What is the radioisotope can be used to determine the age of fossil? The answer is carbon 14. Okay, So this one just the objective answer. Okay, now I need to go is the structure. Okay, let's see some structure question. Okay, question is number 9. Okay, we go to understand the question first. Okay, first one, they say about the source and also detector are used to check the level of the fruit juice in the carton. Carton of the fruit juice, they pass between the detector and radioactive source. The radioactive source is a beta particle. Okay, now we go to answer. State the name of the suitable detector to detect the beta. So I told you detector we got 5 types, is it? Okay, the simple one we every time to use one is a G dot M capital tube. GM tube. Okay, what is beta particle? So beta, what's the meaning? Fast moving electron. Okay, this one is a definition for beta. Okay, explain why the level of the detector radiation fall when a full carton of the juice goes past the detector. Why the level drop? So because the fruit juice is more or less, okay, must be, okay, they say detector radiation detect when the full carton of the juice pass through. Okay, full carton means over level. Over level, what happened for the detector radiation? They will drop. Why will drop? Because the beta is absorbed by the fruit juice. Okay, some of the beta absorbed by the fruit juice, so that's why the reading pass through will drop. So we just write beta particles are blocked by the fruit juice. Okay, then we go to explain why a source of emitting alpha particle is not used. Why we never using the alpha? Okay, reason alpha is low penetrating power. So if no penetrating power means that it cannot pass through the fruit juice. Don't say fruit juice, carton also cannot go in. So they say carton. Okay, cannot pass through the cartons. Okay, now if you say alpha cannot use, why gamma also cannot use? Gamma is high, too high already, is it? Too high of penetrating power. Too high also cannot use. Too high means you go through already. How to detect? Okay, then we go to the question number 10. Okay, they show you the process of the controlling the thickness of the metal plate. Metal plate, metal plate strong already. So from here got ruler, the reading obtained in the table. Okay, can you see that using the plumber box? There's a lead box. Lead board normally there is a gamma source. Okay, now you can see the readings. Okay, 200, 250, 180, 202, 197, 201. Okay, can you find here some got problem already? Okay, the standard 200. Then we got 202, 197, 2101. Okay, the other is okay. Maybe this one and this one got a little bit problem. 250 big problem. Okay, now we're going to see the first one. Name the detector P. Okay, remember detector we always using is a GM tube. Geiger-Müller tube. Why the gamma source is used? Okay, because you are metal plate, is it? Gamma source is used because of high penetrating power. So it can penetrate the metal plate. You also can say there's a high penetrating power lah. Okay, the next one is why gamma source is placed inside the light box. Okay, remember, if we put inside the normal box, the gamma will be escape. So from here you want to safety, we put inside the light box. So from here you want to prevent the gamma, prevent escape to the surrounding. Okay, now at what position the metal is very thin? Very thin. Very thin means what? Very thin means, okay, example I draw. Okay, this one is a thick one. This one is a thin one. Thin means all the gamma can go through. All the gamma can go through, reading will become highest. Okay, so this one should be the thinner lah. B become the thinner, C become thicker. So that's why some cannot go, reading become drop. So now the question they ask you which one is a thin. So the answer should be position B. Okay, position B become thin. Can you give the reason? Reason is because of the highest reading lah. Because of the highest reading, so we know that one is a thinner. Highest reading recorded. Okay, then the next one is explain why the thickness of the metal plate at the position A, D, E, and F same, but with the different. Remember, I told you already, you cannot get the perfect number, or 200, 200, 200. No, they got affected by the background. It affected. Okay, I'll just write here by the background readings. Okay, affected by the background readings. Okay, the next one is what happened to the reading of the counter if a part of the metal plate attached with the magnet? If I put the magnet, what you think about the reading? So you need to think back lah. What particle we using? We're using gamma, is it? Then I put the magnet. Actually, gamma is not detected with any magnet. You put a charge, you put a magnet, gamma also no effect one. So suppose your answer is unchanged. Okay, nothing happened, unchanged. Okay, if the gamma source is removed, what happened to the reading? Okay, the reading must be decreases. No gamma already, so that's why decreases. So the reason is no gamma radiation pass through. Okay, it just show the background readings. Okay, they just show the background reading, so that's why the reading will be dropped. Okay, so this one is what I want to show you about the tutorial from the 5.3. So they're just a simple thing. Okay, nothing to be more about that. So hopefully you understand now why I'm talking about this. So now for the student, you are still not yet to learn about 5.3, so better you learn first before you go and see the tutorial answer. Okay, for the student, you are finished already, that means you can check the answer here. For the objective, if you still do know, okay, why the answer become like that, for the structure also can. You also can be PM me, then I will answer for you. I'll give the explanation why the answer become like that. So hopefully you can follow my lesson. So the chapter 5, hopefully this holiday I can finish it. So that means when the school just open, I will continue my chapter 3. Okay, chapter 3, finish it, then we just got left one more, that's a chapter 4. Okay, and after that the whole Form 5 syllabus we can finish. So thank you for watching lah. So